Imagine a being so vast, it does not move through space. It contains it. To this being, every choice you have ever made, every world that could have existed, every timeline branching from every quantum coin flip is laid out like a single motionless object. That object has a name in physics. It has 10 dimensions. In the next 12 minutes, we are going to do something careful. We are going to take the popular idea of the 10th dimension, the one you have seen in viral animations, and hold it up against what string theorists, mathematicians, and cosmologists at institutions like CERN and the Institute for Advanced Study actually mean. The two are not the same, and the real version is stranger, more disciplined, and far more humbling than the YouTube myth. For most of human history, 3 dimensions were enough: length, width, height. Then in 1908, the mathematician Hermann Minkowski formalized something Einstein had just shown. Time is not separate from space. It is woven into it. Reality, Minkowski said, is 4-dimensional, a space-time, and we live inside its fabric like fish inside water, unaware of the medium that carries us. Then, in the 1920s, 2 physicists, Theodore Kaluza and Kaluza-Klein, proposed something audacious. What if there were more dimensions, but they were curled up so tightly we could never notice them? Imagine a tightrope seen from far away. To a person, it is a 1-dimensional line. But to an ant on its surface, there is a 2nd dimension wrapped around the rope's circumference. Kaluza-Klein theory suggested our universe might have hidden dimensions, compactified at scales far smaller than an atom. This idea sat dormant for decades. Then in the 1970s and 80s, a new framework revived it. String theory proposed that the fundamental constituents of reality are not point particles, but tiny vibrating strings. And here is the strange part. For the mathematics of string theory to be self-consistent, for it to avoid producing impossible results like negative probabilities, the strings have to vibrate in exactly 10 dimensions, 9 of space, 1 of time. This was not a guess. It came directly from the equations. Edward Witten of the Institute for Advanced Study would later unify the 5 competing versions of string theory into a framework called M-theory, which requires 11 dimensions. But the version most physicists work with, superstring theory, sits firmly at 10. So when someone asks about the 10th dimension, they are usually asking about this: the final dimension required by the most ambitious theory of everything humanity has ever attempted. The 6 extra spatial dimensions are believed to be compactified into shapes called Calabi-Yau manifolds, mathematical objects of extraordinary complexity. If string theory is correct, every point in the space you are sitting in right now contains, folded inside it, a 6-dimensional geometric object roughly 1035 meters across. That is the Planck scale. About 100 billion times smaller than a proton. So what would it actually mean to access these dimensions? To answer that, we need to be precise about what access means. There are at least 3 serious scientific interpretations, and they are very different from the cartoon version. The first is energetic access. According to the standard string framework, to probe distances near the Planck scale, to see a curled-up dimension, you would need a particle accelerator with energies near 1019 giga-electron-volts. The Large Hadron Collider at CERN, the most powerful machine humans have ever built, reaches around 104 giga-electron-volts. We are off by a factor of roughly a quadrillion. To build a collider capable of directly observing a 10th dimensional structure, by some estimates published in journals like Physical Review D, we would need a ring larger than the orbit of the Earth around the Sun. The second interpretation is gravitational. In some models, particularly the large extra dimensions scenario proposed by Arkani Hamed, Damopoulos and Diwali in 1998 published in Physics Letters B, gravity is weak compared to other forces precisely because it leaks into extra dimensions. If true, this would mean gravitons, the hypothetical particles carrying gravity, can travel through dimensions we cannot. Experiments at the LHC have searched for missing energy signatures consistent with gravitons escaping into extra dimensions. As of the most recent ATLAS and CMS results, no such signal has been confirmed. But the search continues. The third interpretation is the most exotic, the holographic one. In 1997, Juan Maldacena published what is now one of the most cited papers in theoretical physics. He showed that certain higher-dimensional gravitational universes are mathematically equivalent to lower-dimensional quantum systems on their boundaries. This is the AD-S-CFT correspondence. It implies, astonishingly, that a higher-dimensional reality and a lower-dimensional one can encode the exact same information. To access a higher dimension in this framework might not require traveling at all. It might require translation. But here is what the popular videos get wrong. They depict the dimensions as a hierarchy of choices: point, line, branch, parallel universe, branch of branches, culminating in a 10th dimension that contains all possible everythings. That is a charming pedagogical metaphor invented by author Rob Bryanton in 2006. It is not physics. Real string theorists do not describe the 10th dimension as the set of all possible universes. They describe it as a spatial direction, just one more axis at right angles to the 9 we already accept on paper. So what would a creature that perceived all 10 dimensions actually experience? If we trust the geometry, such a being would not see the future or alternate timelines. It would see the inside of every atom. It would see the curled topology of every Calabi-Yau manifold at every point in space simultaneously. It would perceive the shape of gravity. It would see why electrons have the mass they do because in string theory, particle masses are determined by the geometry of the compactified dimensions. In other words, accessing the 10th dimension would not give you godlike power over reality. It would give you the answer to why reality is the way it is, why there are 3 families of fermions, why the electromagnetic force is roughly 1036 times stronger than gravity, why the cosmological constant has the small, strange value it does. The 10th dimension, if string theory is correct, is where the constants of nature are written, and we cannot read the tablet. Not yet. Possibly not ever, given how the energy scales work out. Here is the twist that almost nobody mentions. After more than 50 years of work, string theory has produced no experimentally confirmed predictions. Not one. Critics, including physicists like Sabine Hossenfelder and Peter Voigt, have argued that the framework may be unfalsifiable in any practical sense. The landscape of possible string vacua has been estimated at 10⁵ different configurations, each potentially describing a different universe. With that many options, some critics argue, the theory can be made to fit anything, which means it predicts nothing. So the question of accessing the 10th dimension splits into 2 paths. On one path, string theory is fundamentally correct. The extra dimensions are real, and someday, perhaps through gravitational wave astronomy, perhaps through cosmological observations of the early universe, we may detect their indirect imprint. NASA's upcoming LISA mission and pulsar timing arrays may yet provide evidence. The CMB itself, observed by ESA's Planck satellite, has been combed for signatures of extra-dimensional physics. Nothing definitive yet, but the door remains open. On the other path, string theory is a beautiful mathematical edifice that does not describe our universe. The 10th dimension would then be like the celestial spheres of medieval astronomy, internally consistent, philosophically compelling, and wrong. We would have to start over, perhaps with loop quantum gravity, perhaps with something we have not yet imagined. Either way, the honest answer to what would it mean to access the 10th dimension is this. It would mean understanding the rulebook of physics from the outside, not power over reality, but comprehension of it, not omniscience, but geometry. The 10th dimension is not a place where gods live. It is, if it exists, a quiet axis along which the universe was assembled. We tend to want our extra dimensions to be magical. We want them to contain ghosts and parallel selves and answers to every regret. The real 10th dimension, as physics describes it, is more austere. It is a folded shape smaller than the smallest thing we can measure, encoding the reasons constants are constants. It is closer to a fingerprint than a heaven. And maybe that is enough. Maybe the most profound idea string theory offers is not that there are extra dimensions, but that the geometry of those dimensions, if real, is the reason anything exists in the form it does, including you, including this moment, including the act of asking the question. We are, in that sense, a consequence of a shape we cannot see. If you would like to keep walking the edge of what we know with us, the careful edge, the honest edge, subscribe. We will be here, looking up.